Okay, so section 3.2 for calculus students. So this one is about using the product and the quotient rules. So the product rule, if f and g are differentiable functions, then derivative of f of x times g of x can be written as f of x times the derivative of g of x plus g of x times the derivative of f of x. So d over dx is called the derivative, or differentiating g of x, differentiating f of x. Alternate form is considered derivative of f of x times g of x with the brackets. So that equals f of x times g prime of x plus g of x times f prime of x. I think the alternate form is easier to recognize because this one shows you what you need to do. So normally the first function we can take the derivative first, or we can take the derivative of the second function first. And then alternatively, and then we just take the derivative of the other functions and multiply the original function of the first one. Okay, so now let's look at that, some of the example. But before we do that, here's another rule you need to follow through. Again, if f and g are differentiable, that means you can find a derivative for both functions. Therefore, derivative of f of x over g of x can be written as g of x times derivative of f of x minus f of x times derivative of g of x over the quantity of g of x squared. Again, alternate form, so d over dx of f of x over g of x. So it's f prime of x times g of x minus g prime of x times f of x over g of x quantity squared. So now let's look at that, some of the examples. So consider that root x is the first functions. So let's say this one is f of x, the first. I'll just call it first and second because you can just change the name for those functions. So again, rewrite it, so this one can be written as g of x equals x to the power 1/2 e to the power of x. So according to the product rule, so we take the derivative of the first function, or take the derivative of the second function, it doesn't matter. So you need to take the derivative of one of those functions first. So let's take the derivative of the first function. We do have g prime of x. So that equals 1/2 x to the power of negative 1/2. Because that's using the power rule, times the second function. We don't change that, just multiply the originality of the second function. And then plus derivative of the second function, then that'll be e to the power of x again. And then derivative of the original functions of the first one, which is what? X to the power of 1/2. And now nothing can simplify, nothing you need to do, so just leave it like that. So g prime of x. And now what about for the quotient? So this one, that requires the quotient rule. Okay, so let's say this one is f of x, and the other one is g of x. So using the quotient rule, so we take the denominator, quantity squared. No matter what the denominator is, always squared it. So now, first thing that I want to do, derivative of f of x. So e to the power of x times the originality of the g of x, so multiplied by 1 plus x. And then minus derivative of 1 plus x. Well, this one, derivative of 1 plus x, derivative of 1 is constant, 0. Derivative of x, then that's 1. So minus 1 times the originality of f of x. And you might be wondering, can I distribute? Can I simplify it a little bit? Yeah, distribute, e to the power of x got canceled. So what's left here? It's x, e to the power of x after you distribute. And then you do have that all over 1 plus x quantity squared. And that's y prime. And this one is quite similar using the quotient rule. So no matter what that is, for the denominator, you always want to square that whole thing. So to the 4th power. So derivative of the top, so that's 1 times the originality of the denominator minus derivative of t minus 1 quantity square. Then that would be considered 2 times t minus 1. And then times t. And then the rest of this, you can expand it, you can multiply it out, simplify if you want to. Or otherwise, just leave it like that. And now, what about for D and E? So for D and E, okay, let's see. So for that one, instead of using the product rule, you can always use the power rule. So basically, distribute it, multiply it out. So w to the power of 3/2 times w to the first power. It's just w to the power of 5 over 2. And then plus c e to the power of w times w to the power of 3/2. So the first one, you can just simply use the power rule. So 5/2, w to the power minus 1, so minus 2 over 2, so it's 3/2. And then this one here, we need to apply the product rule. So c to the power of w, so that's considered f. And then w to the power of 3f, that's considered what? G. So derivative of f, then that'll be c e to the power of w times g, w to the power of 3/2. And then plus derivative of w to the power of 3/2, so then that'll be 3/2, w to the power of 1/2. And then times the original function of the f of x. So c e to the power of w. And obviously this one you can take out the greatest common factor if you want to. And it looks like there's no like term here. Okay, so that's for D. And now what about for E? So for E here, so again, we got numerator, denominator. So started off with the, well, let's just try to simplify it a little bit because that would be easier because that involved with fractions of another fractions. So try to rationalize it, multiply by x top and the bottom. I want to rationalize it because that's the common denominator. So what we got here is x squared over x times x squared, a over x times x, so plus a. So now from here you can see that the top and the bottom, there's no more fraction involved. So again, using the quotient rule. So quotient rule is saying that, well, denominator, you always want to square it. So x squared plus a, quantity squared. So started off with the numerator, derivative of the numerator, 2x, times the originality of the denominator. And then plus derivative of the denominator, so that would be what, 2x? Well, constant, that's just 0. And then times the original numerator, times x squared. So eventually this one is considered 2x. You can distribute if you want to, 2x cubed plus 2xa, and then plus 2x cubed, right here. All over x squared plus a, quantity squared. And obviously you can combine the like terms. So 2x cubed plus 2x cubed, then that would be 4x cubed plus 2xa, all over x squared plus a, quantity squared. So again, once you're getting used with the structure, so that's the way you want to do it. If you're not quite sure about the structure, you can always set up the name, f of x, g of x, and then follow through the pattern for the quotient rule, the product rule. Okay, so now find the equation of tangent line and normal line to the given curve at the specific point. Tangent, that means we're using the exact same slope. If that's normal, that means perpendicular. So back to geometry or algebra 1. If two lines are perpendicular, so that means the slope got to be negative and reciprocal. So now let's find the derivative in general first. So using the product rule, so we do have f of x, which is what, 2x. And then g of x, which is what, e to the power of x. So set up the name. So derivative of f, which is what, 2, times the original g, so e to the power of x. And then plus derivative of g, which is what, e to the power of x. And then times the original f, times 2x. And now we want to find out the slope here exactly. So find out the slope, the exact value. So then that would be y prime of 1. So plug in a number. So 2e to the first power plus e to the first power times 2 times 1. So 2e to the first power. So 2e. So the other 2e. So which is what? 4e. Again, this one is just the slope. The one that we found. The instantaneous rate of change at the position of 1, 2e. Write an equation of a tangent line, so that means it requires the points law form. So y minus y1, okay, x1, y1. So 2e, so that equals the slope, which is what, 4e times x minus 1. And then try to simplify this, so 4ex minus 4e plus 2e. Take that negative 2e to the right hand side, so add 2e, so minus 2e. And that's the equation of the first tangent line. Well, there's only one tangent line here at that point. But the other one that we want to find out is what? Normal. So this one is tangent. But now we want to find out the other one is normal. Again, normal, that means, implies that as what? Two lines are perpendicular. So again, using that, the general slope formula. So y prime equals 2ex plus 2x e to the power of x. So we found the slope already, which is what? 4e, the one that we did earlier, previously. And now this time, the slope going to be what? Negative and reciprocal. So we need to convert that to slope to negative reciprocal, so it's negative 1 over 4e for the new slope. And then using that and put it into the point slope form, so y minus 2e, so that equals negative 1 over 4e times the quantity of x minus 1. And then the rest of this, isolate that variable, so negative 1 over 4e times x. And then minus negative 1 over 4e. Well, negative negatives, then that'd be positive. And then plus 2e. So we got y equals negative 1 over 4e times x. Negative, well, negative, positive. So 1 over 4e plus 2e over 1. Common denominator, that's 4e. So this one can be written as 1 plus, multiply this one by 4e, top and the bottom. So it's what? 8e squared. So this one can be written as plus 1 plus 8e squared over 4e. Again, the value of e is 2.70 something. Okay? It's an irrational constant. So we found the equation of a tangent line, and we found the equation of a perpendicular line at the point of 1, 2e. Okay, so now what about the graph? Okay, we'll deal with that later, but let's talk about this one in general. So where g of 1 is 2, g prime of 1 is 5. So you want to find out f prime of 1. Okay, so we do know that the value of x is 1. Okay, so one thing that you notice. And we also know that the point, the instantaneous rate of change. So the point of g of 1, 1, 2. And the other one is what? G prime of 1, which is 5. But now you want to find out f prime of 1. So we do know that f prime of x, using that the product rule, so we do have e to the power of x times g of x, and then plus g of x times what? E to the power of x, using the product rule. So plug in a number, find out what f prime of 1 is. So we got e to the first power times g of 1 plus g prime of 1 times e to the first power. So f prime of 1, so that equals e times what? G of 1 is given already, times 2. Plug in a number, so g prime of 1, it's also given, which is what? 5 times e. So 2e plus 5e, guess what? 7e. And that's all you need to show. And the other one is quite similar, so the product rule, the quotient, so using the product rule. So we want to find out u prime of 1. Well, let's find out the structure of u prime of x first. So using the product rule, f prime of x, okay, excuse me, so f prime of x, so times g of x plus g prime of x times what? F of x. So using that, the original formula. So u prime of 1, so it's f prime of 1, g of 1 plus g prime of 1, and then f of 1. So what's f prime of 1? According to the formula right here, f prime of 1. Well, that means we need to find out the rate of change of this line segment. If you just count it, rise over run. So it looks like this one is 1, 2, 3, 4, 1, 2, 3, 4. So down 4, 4 over to the right. So the slope here is what? It's all negative 1. So the slope here, it's all negative 1. So it's negative 1. What about g of 1? So g of 1, so that means we just want to find out the position, the y value. So g of 1, so that's somewhere over here. Looks like that one is what? Negative 0.2. And then g prime of 1, so what's g prime of 1? So what's the slope of this line segment here? Again, g prime, that means finding the slope. So count it, rise over run. So from the arrow all the way to the point here. So 1, 2, 3, 4, 4 unit down. 1, 2, 3, 4, 5, 6, 7. 7 unit to the right, so it's negative 3 over 7. And what about f of 1? What's f of 1 right here? So that's about, well, here's 1, here's 2, here's 3, but here's f of 1. I would say that's about 2.2 or 2.1? 2.2. And then the rest of this, just wanting you to evaluate. So negative 1 times negative 0.2, so positive 0.2. But this one is a fraction, so let's convert that to a fraction. So minus 3 over 7. So 2.2 in terms of our fractions, which is what? 2 and 2 over 10, 2 and 1/5. 2 and 1/5, which is what? 11. 11 over 5. 2.2, so 2 and 2 over 10, which is what? 2 and 1/5. And it's 11 over 5. And then 0.2, so that would be 2 over 10, which is 1/5, minus 33 over 35. Multiply this one by 7, top and the bottom, so 7 minus 33. So then that would be negative 26 over 35. And that would be the results for u prime of 1. And then for the quotients, so pretty similar. So for the quotient, so using that, the quotient rule. Okay, so using the quotient rule and also finding the positions on the graph right here. So that one is about f5. Okay, so let me just erase this. Just want to get some space. So quotient rule. So v prime of x, which is considered f prime of x, times g of x, minus g prime of x times f of x, all over g of x quantity square. So v prime of 5, so that would be considered f prime of 5 times g of 5 minus g prime of 5, and then f of 5, again the value of x is 5, all over g of 5 quantity square. So let's find out what g of 5 is. So g of 5, so 1, 2, 3, 4, 5 up here. So this one, it's about I would say 2.5 or 2.6. Okay, let's just put in 2.5. Okay, so g of 5, 2.5. And now let's find out f prime of 5. So at 5 here, what's the rate of change of f of x? So count it, rise over run, 1, 2, 3, 4, 5, 1, 2, 3, 4. So it's negative 5 over 4. Negative 5 over 4, negative 1 and 1/4, which is negative 1.25. And then g prime of 5, what's g prime of 5? So at this position here, so that's about 2.5. But the thing is that it's the rate of change. Rise over run, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So 6 over 5. So 1 and 1 over 5. Which is what, 1.2? And then times f of 5. So f of 5. So it's the same position of g of 5. It's the point of the intersections, which is what, 2.5? And then the rest of that, just do it on the calculator and find out exactly what it is. Or you can convert it to a fraction, multiplied it, simplified it. Okay, so just finish that. And that's it. So pretty much that's all the notes for 3.2. So you're more than welcome to watch the video over and over again. Again, focus on the one that you need more time, especially the structure about applying the product rule, the quotient rule, the formula. Alright, so I'll see you guys next time. So you guys have a great one. Take care. Bye.